All right, let's move on to question number 6 of the same paper, November 2016. Now on question number 6, we are given g of x, which is negative 2 to the power x plus 8. What we need to notice here is the format. G of x, generally, it's a times b to the power x plus q. So the negative is telling us the value of a, and we must know the effect of a. If a is negative, it means the graph is below the asymptote. And then q is giving us the asymptote. So we already know the value of q, or the asymptote there. That is y is equal to 8. Alright, let's get to answer the questions. Write down the range, the range of g. Now, we can see that the graph is below the asymptote, which is y is equal to 8. So the values of y, they are all below 8. So we are saying 6.1. The range is simply y is less than 8, strictly less than 8. Or you can write y is an element from negative infinity to 8, and then you put the bracket also to show that 8 is not included. Alright, 6.2, determine the coordinates of b. Now b is the x-intercept, and we all know that on the x-axis y is equal to 0. So we just take our function g of x is equal to negative 2 to the power x plus 8. So g of x at b is 0. So that's equal to negative 2 to the power x plus 8. Now if we take negative 2 to the power x to the left side, it becomes positive. That is 2 to the power x is equal to 8. And this is an exponential equation. That means we have to write 8 in powers of 2. So 2 to the power x is equal to 2 to the power 3. If the bases are the same, we have also the power to equate the exponents. Because for these to be equal, they have to be raised to the same exponent. So we're saying, therefore, x is equal to 3. So at b, x is equal to 3. So we need now to write the coordinates of b is 3, y is 0. And then 6.3, if g is reflected over the x-axis to form a new graph h, determine the equation of h. So 6.3, we are reflecting g of x along the x-axis, and we know that if we reflect a graph along the x-axis, our h of x, we'll get it by multiplying f of x by negative. That is reflecting along the x-axis, because it is the y-coordinate that changes. Remember, if you are having a point 32 and then you reflect it along the x-axis, that is the x-axis is the middle line, the point will be directly on the other side of the x-axis. So what will only change is the y-coordinate. The x-coordinate will remain, but the y-coordinate will be now negative 2. So it means we are multiplying the y-coordinate, which is f of x, by negative. So we are saying the reflection of f of x to give h of x will be negative into negative 2 to the power x plus 8. So this will give us 2 to the power x minus 8. And you can even also tell that even this asymptote will be on this side where at -8. So it's also expressed here. And also the graph will now be above the asymptote line. So basically, if we are to show, if we reflect, this will be down here at -8. That's where we are going to have our asymptote. And then just a reflection, this will now reflect to, and then this part will reflect to. So they meet here at the point on the mirror line. That's where they also cross there, because they are sharing this mirror. All right. So our h of x will be equal to 2 to the power x minus 8. And then the last question, explain why the x-intercepts of G and H are both at B. It is because that this is the mirror, and here at B, y is equal to 0. And they share the same intercept, y equal to 0. So if you use y equal to 0 on H, you get the same answer as use y equal to 0 on G. So basically, we know about the mirror, that if you touch the mirror, that's where your reflection also starts. So you have a common point here at the mirror line. So that is, we can explain this by saying they share the y coordinate, y equal to 0 at B. So using the y coordinate on G of x and f of x is the same. So they share y equal to 0 at B. Alright, that's basically how you could have answered this question. I hope you try the question before you bring the voice behind the